The broadcast is now starting. All attendees are in listen-only mode.
Good evening, ladies and gentlemen. Welcome to Sporty's webinar on weather fundamentals and strategy. I'm your facilitator for this evening. I'm Eric Radke with Sporty's Academy. By virtue of the popularity in terms of the number of registrations we have tonight, I know this is a topic of interest to all pilots, and as it should be. You know, weather and aviation are so closely integrated. We all must be good students of the weather and have a constant curiosity of what's next and be up to date with the various sources of information. You can't ever separate one from the other, whether you're a local flyer, student pilot, or fly regularly in the instrument system. A few housekeeping items before we get to our kind of expert panelists tonight. I'd like to let everyone know that we are recording tonight's presentation. So if you do have to step away at any time, or if there is a specific point that you might miss, do know that you'll be able to come back to this recorded presentation in a day or two via Sporty's YouTube channel or in our webinar archives at sportys.com/webinars. That's where you can also check back for any future presentations. This is part of an ongoing series of informative presentations on a variety of topics. So we're delighted to have with us tonight, speaking specifically on weather, broadcast meteorologist and aviation enthusiast, Mr. Scott Dimmich, and also Bret Koebbe from Sporty's, Vice President, Senior Flight Instructor, and also editor of iPad Pilot News. One additional note in terms of the GoToWebinar platform that we are utilizing tonight, do feel free to submit questions via the software throughout the presentation, and what we will do, we will hold those questions, we will gather those for a specific Q&A period at the end of the presentation for both Scott and Bret. With that, I want to thank both Scott and Bret for being on with us, and I'm going to turn things over now to Bret Koebbe.
Thank you, Eric, and welcome everybody this evening to the webinar. A couple of things first, as Eric mentioned, my name is Bret Koebbe, flight instructor primarily at Sporty's Academy, and produce our aviation training content, of which a big portion of that is aviation weather training content. And my partner in that is Scott Dimmich, as Eric mentioned, a aviation enthusiast and our head meteorologist at Sporty's Pilot Shop, and the head weather expert for all of our training courses, both in private pilot and instrument training. Scott is also our primary weather author and video talent in our Takeoff app, which is a daily way for existing pilots to get weather content, tips and things. A lot of content we're going to talk about this evening, for example. Tips like that you'll find in the Takeoff app for your iPad and iPhone, and I'll mention that here shortly, how you can get that towards the end. As Eric mentioned, Scott's also a certified broadcast meteorologist here in Cincinnati with more than 10 years of on-air and operational forecasting experience. So he's going to share a lot of what he's learned over the years with weather throughout the evening. So the way this is going to work, we're going to Scott and I are going to go back and forth. Scott's going to focus on 3 different topics in aviation weather, and then I'm going to bring in more of the pilot side of things, how you take these aviation theories and concepts and apply them to your weather briefings, how you apply them to your in-flight decision-making. So you're really going to get both sides of the weather picture, how these tools are developed from the meteorologist side, and then how you can apply them in your daily aviation flying. So we're going to look at aviation weather forecast models. How are these forecasts developed? What goes into them? And what side of it is computer-based and what side actually has human intervention? Because that's very important when you're taking a look at the weather and weather forecasts. From there, we're going to dive into aviation weather hazards. And primarily, given that it's May and the spring flying season, and it's really a thunderstorm season for most of the United States, we're going to focus on some convective weather and how to expand your weather toolkit, some weather forecast tools in ForeFlight and from the Aviation Weather Center online that you can look at to really expand your weather briefing and take a different approach to your pre-flight weather briefing that you may not be using now. From there, the third step of that, we're going to look at in-flight weather avoidance, which is really the hot topic item as the technological advances have made their way into general aviation aircraft with ADS-B weather, the free datalink system, and Sirius XM datalink. So we're going to go through a series of in-flight scenarios and show how the weather develops using those products and how you can use them effectively to complete trips that really you may not be able to without having those tools in the airplane. So that's kind of an overview of what we're going to cover. At this point, I'm going to turn it over to Scott here, who's going to get us going on the weather forecast models and share how these weather forecasts are developed. So with that, I'm going to give it over to Scott here.
Well, first of all, I want to say good evening, everyone. Thank you very much for having me. Thank you very much for tuning in tonight. Thanks to Bret. Thanks to everybody at Sporty's for having me as part of the team. The screaming message for tonight that I want to pass along as a meteorologist is that there is an emergence of technology, but you should always trust your own instincts as a pilot. You should never let technology make decisions for you. Make sure that you are using your own judgment to make the right call before you get into a situation that you do not want to be in. So with that being said, I want to first start off with what a weather forecast model is. You may have heard the term, but you may or may not be familiar with how a weather forecast model works. Simply put, computers take radar data and satellite data, data collected by weather balloons, which are usually launched twice a day from various National Weather Service forecast offices and around the globe. Also surface data, what you're used to seeing in the form of a METAR, and a whole bunch of other data, including ACARS data, which has been a recent add to a lot of computer forecast models in just the last 10 or 15 years. All of that data is then collected and assimilated by a computer. In the case of the National Weather Service, a supercomputer that is used to predict future weather changes. So a computer forecast model is exclusively to be used in the future. So you should always be able to see what's going on now and then compare it to what computer models are projecting for the future. These computer forecast models must be able to simulate changes in the weather over both time and space. Without an understanding of both, computer forecast model really isn't a computer forecast model, and the quality of it will likely be significantly reduced if it can't successfully understand the changes in both. Now, while computer forecast models are an important tool, remember that meteorologists often interpret this data to then make a weather forecast, including in the form of a TAF, which you may already be using as a pilot. Let's first dive into the two main types of computer forecast models. The first, and perhaps the most important, being numerical weather prediction. And I'll keep this as simple as I can, but supercomputers are basically using complex mathematical equations to convert current weather conditions, everything that we talked about in the form of satellite, weather balloon, radar, surface data, into a future state of the weather. Usually when you're looking at raw model data, you're looking at numerical weather prediction. But there, especially in the form of ForeFlight, but also in other places online, statistical guidance is becoming more and more common to pilots and is being used more and more frequently by those that are outside of the meteorologist circle. Statistical guidance compares NWP data, numerical weather prediction data, to past observations and then attempts to correct common biases or errors in those models. For example, a computer model may have a habit of going too warm on afternoon high temperatures in certain weather patterns. Statistical guidance usually comes in and attempts to correct that. As you might expect, forecasts are not always high quality. Confidence in a forecast usually decreases with time. So you should expect a 7-day forecast to be less accurate than a 1 or 2 day forecast. That's not always the case, but that's a general rule of thumb that you should follow. And confidence is usually higher for larger scale weather features, cold fronts, positioning on high pressure, as opposed to individual clusters of showers and thunderstorms. Computer models, at least most of them, forecast for various spots around the globe or around a given area, and then something called parametrization works in the background to simulate smaller scale features like thunderstorms. So know that most models don't directly forecast thunderstorms. And computer models rarely are accurate with the exact placement and positioning, but you should be looking at trends. The trend is your friend. Don't fall into these pits. This is where pilots and meteorologists usually fall into a trap. Don't believe that higher resolution computer models are more accurate. Higher resolution computer forecast models simply just produce higher resolution output. The latest run of a computer model isn't necessarily the most accurate. If bad data gets ingested into a computer forecast model, including into statistical guidance, it's not going to produce very good results. So it's more important to focus on the trends when looking at model output. And remember that rapidly updating models, which is something that has really accelerated in the last 5 to 10 years, aren't necessarily the most accurate. Again, the trend is the most important thing to see. And beyond that, you want to make sure that you're using not just computer forecast models, but you're also using current trends, METARs, TAFs, radar, other data to make decisions. So no computer forecast model is perfect, and no human forecast is perfect. You should never expect a TAF or any other aviation forecast to be perfect all of the time. Meteorologists, however, often have a skill beyond one computer forecast model or even a blend. So there is still a need for meteorologists to produce forecasts, including for the aviation community. Forecasters often compare recent weather trends to computer forecast models. And you can do this as a pilot too. If a computer forecast model is saying there will be showers and thunderstorms in the next hour, and you're not seeing clouds developing, or you're not seeing showers or thunderstorms downstream, you should incorporate that analysis and then compare it to what you're seeing in the computer forecast model before you make a decision. Aviation forecasts are usually coming from the National Weather Service, including the convective outlooks, TAFs, surface maps. Those, at least in the United States, are typically produced by the National Weather Service. And they are updated throughout the day. You might expect to see them at 0, 6, 12, 18Z. And especially with the advent of ForeFlight and other devices in the cockpit, you should be reviewing forecasts and observations as frequently as possible. Back in the good old days, it used to be before your flight, but now, more than ever, especially with iPads in the cockpit, you should also be doing that during your flight as well. So in summary, we've talked about numerical weather prediction and statistical guidance. As a pilot, you should focus on these things. A TAF is a terminal aerodrome forecast, and that's a forecast in the United States created by a National Weather Service meteorologist. These are only valid within 5 miles of an airport, and usually valid, depending on where you are in the country or the world, out to 24 or 30 hours. And in the example that you see here on the screen, you see the letters A and D standing for amended. Know that TAFs are issued often more than 4 times a day. If a meteorologist has really messed up a forecast, they're going to make every effort to go back and correct that forecast based on current trends. And you as a pilot should also be checking to make sure the METAR that you're seeing matches up with what the TAF is producing and if it's realistic. And we also talked about model output statistics, which are available, especially recently in ForeFlight. That is statistical guidance, a computer-generated, non-human forecast that is taking numerical weather prediction model data and correcting it for common errors. So that is a very simplistic explanation of how aviation forecasts are developed. At this point, I will be handing it back over to Bret, who will talk more about taking these weather forecasts and putting them into action.
Okay, thank you, Scott. I'm going to take the screen back over, and we'll continue on here. So as Scott mentioned, and really as pilots, we're taught this from the very beginning during our primary flight training days, from a forecast standpoint, that we look to that terminal aerodrome forecast, the TAF, when determining weather around a particular airport. And the TAF is great. It's very useful, and we use it every time, but it's really constrained if you think about it. It has to follow the same format of the winds, the visibility, the cloud coverage, and that's good, but it doesn't really give the big picture of what's going on around the airport and what the meteorologist was thinking. I'm sure many times they probably are frustrated and want to get more information in there to pilots, but they physically can't due to, which is good, the limiting size of the TAF. So something I want to bring your attention to, and in this example and throughout here, we're gonna use ForeFlight as our example model here for the app. Again, everything we're going to show is available on the Aviation Weather Center website. But again, being ForeFlight is probably the most commonly used aviation application out there, and they do a good job of pulling in these resources. We're going to use this as our template. But if you look there on the Airports tab, here we are looking at Plattsburgh International in New York, and we're on the weather section, and we see the familiar METAR, TAF, MOS, MOS. We're going to talk about that here in a minute also. But we're on the Forecast Discussion tab. And this is something you really should make part of your briefing, whether you're a private pilot, instrument pilot, etc. And what this is developed for various regions around the country, roughly the size of a large city, sometimes larger based on population and the size of the state. But it's basically what the meteorologist and the forecaster was thinking when they developed that forecast for that airport. And it gives you a sense of their confidence level, which I think is really important. This time of year, we see the common symbol in a TAF, which is VCSH, showers in the vicinity. That's great. That kind of says, okay, be aware, but that doesn't really tell you a whole lot. Sometimes that evolves into severe thunderstorms. Sometimes that evolves into a light rain shower with 10,000-foot ceilings. Not a lot of information there about what that means. But what you can see here by reading these forecast discussions is the forecaster basically wrote what they were thinking when they developed that TAF forecast. And especially in areas that you're not too familiar with, maybe that have some terrain influences out west or near coastal regions, say California, if you're not used to flying in those areas, they have predictable weather patterns, and the forecaster will bring those in and kind of explain why he thinks the conditions exist the way they are and what the likelihood of them changing throughout the forecast period is. So check that out there in ForeFlight during your next self-weather briefing. The same tool here, we're looking at the Aviation Weather Center website. Again, we're on the aviation forecast discussion, and that map there of the United States shows the grids of how they are broken up. So you can see there are several forecast regions per state, and you can click on any one of those to view that aviation forecast discussion and get that additional information. It's going to take a little practice if you're not using these now, and a little bit of training to work your mind into thinking that way, but it really is helpful, and you'll learn a lot about the weather along the way as to what's causing the certain conditions that you're seeing. Okay, Scott talked a lot before about the model output statistics. On the left side there is the raw data, that blue grid of numbers and letters and symbols that is output by these computers. And as he mentioned, these are computer-based forecasts. There's no human intervention here, but they are beyond models. They take historical data and use statistical information to improve those forecast information. From a pilot perspective, this is great in addition because they're available for over 2,000 airports throughout the United States. Many know who fly in rural areas outside of the bigger cities. The TAF forecasts are only available for those larger airports. So you don't really have that hour-by-hour forecast when you're out in the country or out away from the big metropolitan areas. And that, in my opinion, from an aviation standpoint, is where the MOS forecast can really come in handy to give you some of that TAF-like guidance in less populated areas. Now again, we're looking at ForeFlight in the Weather tab there. Under the TAF button, you see the MOS button. And it's going to be a very similar layout to what you'd expect with that TAF, with the wind forecast, visibility, clouds. These will go out to 3 days in the future. My experience, beyond about a day, they kind of get a little run. You know, they're not too accurate from compared to what a human forecaster is going to tell you. But I can give you a feel again for long-term trends. If you're looking a couple of days out, you might be able to gather some guidance on the trends of what's going on. But for that shorter term period, it's another tool to look at and compare to the TAF to see how they line up for your flight that day. Now, the Aviation Weather Center also creates several graphical depictions of some of the data that the MOS outputs. And again, here we're looking at ForeFlight. Now we've jumped over to the Imagery tab. If you look at the left-hand screen here, the Imagery tab contains a lot of dedicated individual weather forecast products that tend to get overlooked, but a lot of what I'm going to discuss this evening is going to be based on what's in this imagery tab that I want you to start incorporating into a weather briefing. If you call LIDO's flight service or do a graphical weather briefing through ForeFlight, you're probably not going to see a lot of these. The standard weather briefing hasn't really changed much over the last 15 years and has not incorporated some of these model output statistics and other forecast data. And a big part of that too is some of these are long-range forecasts. So what we're looking at here is a ceiling forecast that goes out to 84 hours based on that model activity and information. And what this allows you to do is look 2-3 days down the road to see what's going to happen around the United States. And what you're looking at here are the black areas, which are the parts of the country that don't have any of the color information on there. In this case, that means basically ceilings above 12,000 feet for this forecast period, which is labeled up here at the top in Zulu time, all the way down to the darker yellows and oranges, which shows ceilings in the 200 to 400 foot range. You're not going to use this as an IFR pilot necessarily to pick your airport for your instrument approach or make very narrow decisions, but again, a good long-range planning tool that can help you get a feel for how things are shaping up over the next few days. Along the same lines, the chart looks very similar. This is actually a visibility chart now. Again, if you look over here on the left-hand side of the imagery tab, we're looking at the visibility forecast. Again, this goes out to 84 hours. But a great tool for private pilots, VFR pilots flying in good weather days to get a feel for what the long-term visibility forecast is again too. And then your code here is at the bottom. So this black area, obviously the middle parts of the country, over 6 miles visibility forecast, but these colored regions here are predicting down to the 0.5 to 1 mile visibility range in the days ahead. So a good tool there. For those not using ForeFlight, all this information is also available on the web. I put the URL, the website there, which is pretty long and not exactly an easy one to memorize. But if you go into any web browser and search for the GFS MOS graphics, you'll pull this web page up here. And you'll see along the left-hand side, it'll break out other products as well based on that statistical model forecast, temperature, precipitation, thunderstorms, etc. And what you may even find, you might start using this to predict your, plan your weekend out if you want to go golfing or maybe not an aviation weekend, but you might use it for just to see what the weather's like over the next couple of days. So a really helpful tool there, again, based on that long range model data. With that, I'm going to turn it back over to Scott. And the next part we're going to dig into is some aviation weather hazards. And really, again, given this time of year, we're going to focus on convective weather. And Scott's going to take over with that.
Thanks, Bret. Very important points there on MOS. Just as a meteorologist, I find that the 0 and the 12Z runs of both models and MOS tend to do really well compared to the, I know that the 6 and the 18Z GFS model MOS will be out there. So you may even see individual changes in models depending on the time of the day. But let's jump into the differences from today and tomorrow. Weather changes frequently. We all know that. And as a meteorologist, it can often be frustrating to deal with volatile changes in the atmosphere, an evolving severe weather threat, an evolving winter storm. But in a pilot's view, most aviation weather hazards are tied to weather. And you'll hear that not just from meteorologists and pilots, but you'll hear that from airport managers and even those that are responsible for investigating crashes, which we never like to hear about, but thankfully you're being prepared and briefed tonight on the hazards related to aviation. Some of the ones include fog, low visibility, thunderstorms, showers, turbulence, and icing. You should be looking for all of these hazards and additional hazards during your briefing. And you should always be alert for changing conditions. We've already talked about the changes in forecasts. A lot of times there's no time for a National Weather Service meteorologist to keep amending a TAF when there are tornadic or severe thunderstorms in the area. So know that changes can evolve in the forecasts and changes can evolve in the atmosphere. So you should always be anticipating changes even before a forecast or a TAF or the radar even suggests that a change will be happening. Let's talk about icing. And this is often something that's addressed in the winter and the colder months of the year, but it can be a summertime threat. First, let's talk about stratiform, and that term may look vaguely familiar, related to stratus clouds. Rime icing is caused by ice, not by ice in the clouds, but instead by supercooled water droplets. And I struggled with this when I was a student at Penn State trying to understand meteorology, but in simple terms, it's just liquid water in a sub-freezing environment. You may say, well, how does that happen? And a lot of times there needs to be a particle in the air. The meteorological term is a cloud condensation nuclei. It can be something as simple as a tiny piece of dust or dirt, something that those droplets can congeal on and then allow it to freeze. Sometimes those particles are there, sometimes they aren't. So just know that you're looking for super cold water droplets if you're concerned with rime icing. The liquid usually freezes on contact with the airfoil, and this is a byproduct of lifting. When air cools and condenses, the two are related, cooling and condensing and lifting. So the water droplets in the supercooled part may be complicating, but most icing occurs between 0 degrees and 20 degrees centigrade, 32, 4 below Fahrenheit, and especially between 8 degrees centigrade and 12 degrees below centigrade. Just a heads up on the stratiform angle, but remember there's the cumuliform angle, and this is the angle that you should be thinking about, especially this time of the year, and especially in the vicinity of showers and thunderstorms. In cumuliform environments, puffy cumulus clouds that tend to tower and are usually the precursor to thunderstorms, the cloud droplets are larger, and the icing often occurs in the updraft part of a cloud and in mature storms. Thankfully, wise pilots like yourself will probably avoid those anyway. So usually the stratiform version of icing is a bigger concern to pilots, but don't forget about this. And especially don't forget about it because the larger vertical extent is there. Remember, towering cumulus clouds can extend thousands, if not tens of thousands of feet, whereas stratus clouds tend to be like pancakes, only 1,000 or a couple thousand feet deep. And by the way, clear icing is most likely in growing cumulus clouds. So you see two different threats. And a lot of times you hear about stability. And I've tried to keep this as simple as I can. Stability as it relates to the atmosphere is a function of the temperature and the dew point. A dew point measurement is an absolute measure of how much moisture there is in the air. And I want to be very clear that relative humidity is not an absolute measure of how much moisture there is in the air. The relative humidity can be 100% early in the morning on a summer day, but it can also be 100% when the temperature is near, below, or just above freezing. So if you want to see how humid the air is, you look for the dew point. And when we talk about stability, we're not talking about the atmosphere overall. Different layers of the atmosphere can be stable, and other layers of the atmosphere can be unstable at the exact same time. And the diagram here at the right is called a skew T log P, which is a diagram meteorologists will use to plot the temperature and the dew point going away from the ground. And we can use the various adiabats and lapse rates, basically how parcels of air, chunks of air will cool and at what rate they will cool at as they ascend and go higher into the atmosphere. Don't need to worry too much about that, but as model data becomes more and more available, you may see terms like CAPE and SIN. And just so you're familiar with those, CAPE is a measure of instability, convective available potential energy, but convective inhibition, or SIN, describes stability. So a lot of times when you see a forecast for thunderstorms bubbling up and the coverage of thunderstorms is a lot lower than what was forecast in the TAFs or in other sources, usually SIN, or stability, trumps instability. You want some stability, especially early in the day, so that you can pressure cook that warm, moisture-laden air And then with time, those parcels will be able to break through that stable layer above the ground and convert that into instability. Convection thunderstorms, you're typically looking for high instability and low stability. Although earlier in the day, you may have a lot of stability and that may get worked out over time. Where are thunderstorms most likely to form? Try to keep it simple here. You want warm air near the ground. The higher the temperature, the better. You want moist air near the ground as well. We already addressed the difference between the dew point and the relative humidity. I like to see a dew point in most parts of the country, especially along and east of the Rocky Mountains, 50 plus. That's almost always needed. And you really want a dew point of 60, 70, if not above 70 for a significant threat for severe weather. You want a low dew point depression near the ground. Dew point depression is a term to describe the difference between the temperature and the dew point. But it's not just what's going on at the ground. You also want cold, dry air aloft. And for more organized thunderstorms, severe storms, tornadic thunderstorms, you want high wind shear. And when we say high wind shear, we mean a large change in the speed and direction of wind with increasing altitude. That supports storm longevity and strength. Also, when we talk about wind shear, we're talking about direction and speed. When you don't have a lot of directional wind shear or change in the direction of the wind going away from the ground, and you're expecting strong or severe storms, as a meteorologist, you're often looking for a damaging straight line wind threat. But if you have a large change in speed and direction, you're often more concerned with not just a damaging straight line wind threat or a hail threat, but also for supercell thunderstorms. So this is something that meteorologists are looking for in the background. And we've talked a lot about storm cues here and tips to look for, but I really want to hit the point here about knowing the difference between technology and knowing the difference between what's outside of the airplane. Cumulus clouds are developing, growing vertically, especially if rapidly. You should be concerned for thunderstorms in the area. Of course, if you've read your TAF, if you've looked at maps, if you've looked at MOS, looked at the probability of rain or thunderstorms, you hopefully are already expecting it. As a meteorologist, we're looking at satellite images, but as a pilot, you may be looking at something like the picture in the lower left-hand part of the screen for an overshooting top. That's often a signal that storms are very strong or severe. And technology is great, but your eyes are a leading indicator of weather. Satellite and radar, even with the modern era of technology, rapid scans, it's still a lagging indicator. So you should be trusting your eyes over technology. Technology should aid in your decision making. It should not make your decision. And radar and satellite data often miss the features that you're going to be easily seeing outside of your window. So make sure you don't miss those visual cues. So to drive the point home, computer models and guidance are becoming readily available online through apps like ForeFlight. But models are not reality. Make sure that you're comparing what computers are projecting to radar, to satellite, to surface trends. See if it makes sense in your mind. Review the trends in the models and avoid just looking at model snapshots like the one you see on your screen. You want to see the evolution of clusters of rain and storms. Different models have different solutions, so don't just look at one statistical output or one computer model. Make sure you look at a couple of them to see if they agree or if they're in a consensus on what will happen. And of course, as a pilot, just as you spend more time in the cockpit, you become more familiar with the operation of the airplane, you'll also become more familiar with models compared to what actually happens in reality, and you'll be able to see these biases. So I'm going to send things back to Bret, who will talk more about how to put this into action.
Thank you, Scott. So what Scott talked about, and a key point here is determine the evolution. And the evolution might be the day of, watching the morning temperatures, dew point, how the clouds developed that day. But what I want to do is kind of take a step backward and really help you formulate the evolution days in advance with your weather knowledge. And then we're going to get up to that point that Scott was just mentioning about the day of. And this next segment, third segment after this, we're going to talk about actually the in-flight portion. But let's start off with this. I see a lot of pilots as a flight instructor and check airmen. You ask them, okay, can you complete this flight? And you observe what they look at, which today is the iPad. So they'll grab their iPad, they'll put the route in. In this case, we're looking at a flight from Cincinnati Lunkin down to Charlotte. They turn the radar layer on, which is good, and then they'll click on the destination METAR for Charlotte. So this flight here looks doable, right? There's not a solid line of weather. There's some breaks in the storms, and Charlotte's great, clear VFR 10 miles and clear weather. Is that really good enough to make a decision that you can complete that flight? Of course the answer is no. We need to know more about what's causing the weather, what's causing those systems to form, and what the expectation is throughout the day from that system. So what I'm going to talk about is kind of that weather briefing concept. And what it is, it's called get the big picture. And that's kind of our general trend of our weather briefing. And if you go to flight service, either through the telephone or through their online tools that are available now through 1-800-WXBrief.com or in an app like ForeFlight through their graphical weather briefing, starts off with a big picture. Things like the surface analysis, where are the high and low pressure systems, where are the cold fronts, how are the isobars shaped together. If you're several days out, possibly a prog chart to see where those low pressure systems and cold fronts are expected to move over the next couple of days. Of course, the radar picture, that's important. We want to know what the precipitation is out there, satellite imagery. And then once you have a feel for what's causing the weather, drill down to the details of the METARs, the pilot reports along your route, the terminal aerodrome forecast, and the other forecast products we mentioned earlier. So now as you read those METARs and read those TAFs, you have a feel for why they are the way they are in terms of what's causing that weather. So always think of that big picture view and then again head down to that lower, more detailed view. Now, unless you're a charter pilot, on-demand pilot, or have trips that pop up without much notice, you typically have several days in advance knowing when your flights are going to depart. That's the flexibility of being a general aviation pilot. Plan this out, leave on your terms. Now, what I like to do in my flying, and the flying I most typically do these days is anything from a Cessna 172 in a flight training environment up to a Cessna citation in a corporate flight department. So I fly the various levels, but no matter what the flight is, I like to start 4 or 5 days out if I can to get a feel for what the weather is forecasted out in that period. And that's going to start off with me pulling up the iPhone, typing in the city I'm going to or the location and look at the little sunshine symbols or the cloud symbols. That sounds silly because that's obviously not a very accurate forecast information, but I'm picking up clues there of what's the temperature look like. Today's Wednesday. Let's say we're planning a flight onto the East Coast on Friday, and I see, tomorrow evening the low drops down 20 degrees lower than today. It's 85 degrees tomorrow in that city, and then on Friday it's 65 degrees. Probably tells me a cold front is moving through, and I'm probably going to see some kind of convective weather, little icon symbol there. So it gets me thinking about what's going on. And I point out that iPhone graphic there just because that's something we always have with us. You can always kind of stay in tune with that weather information. So from there, my weather curiosity peaks at that point. Again, for this flight a couple days out, I'm going to head over to the surface analysis and the prog charts and get a feel for the big picture weather patterns, where the low pressure and high pressure systems are, and how they're going to progress over the next couple days. The next two charts, the one in the middle here that's kind of white with some blue, that's our extended convective forecast product, and I'm going to talk about that in more detail shortly. It's going to help explain thunderstorm development when forecasters think over about a 6-hour period where thunderstorm activity might take place out to about 3 days out. So a very useful tool, again, for long-range planning. Then I'm going to take a look at this next one here, which is a probability of precipitation. So it's showing areas where precipitation is likely to form, again, 3, 4, 5 days out in the future. And again, I'm looking at these charts trying to think, again, as Scott mentioned, it takes really precipitation to create these weather hazards. A clear blue sky day, yeah, might have turbulence. That's definitely a possibility, but we're not going to have this thunderstorm activity. We're not going to have the icing potential like we do when we have low pressure systems and troughs that develop those weather hazards. So now, come Friday of our planned departure time, I can take a look at that radar picture, and I can see the convective activity, the storms, the real-time events, but I have a feel for what's driving that. And by watching those trends, out to 5 days out, you can see how the forecasts evolve. A lot of times you'll see a cold front predicted on one day, and then I'll move it forward a day or two as time gets closer. And as Scott mentioned, those model forecasts get more accurate the closer you get to that actual day that you're looking at. So if you can get that habit, I think it really helps. And don't just think of it on the days you're flying. I like to look at the weather a lot, even on the days I don't have a trip planned. Again, that helps you learn and see how things evolve and how the forecasts evolve. So of course, like I said, start with your weather briefing. You're going to look at your surface analysis chart. We all learned that again in primary training, and instrument pilots also spend a lot of time analyzing these and some upper level charts. But get a feel for what's out there, what's causing the weather. But from there, I want to take it a step further. This is what I want to call expanding your weather product toolkit. Everything here we're talking about is again available online. I'm going to show you where they are in the ForeFlight application, just because of how nicely they're organized there in the application. But 3 charts we're going to take a look at: the probability of precipitation, convective forecast, and the convective outlook. And you've probably heard of the convective outlook. That's been around for a while. Meteorologists refer to it a lot on regular TV, general consumer type forecasts when predicting severe weather, but also very useful from an aviation standpoint. So when you head over into ForeFlight, again, we're here in the imagery section. On the left-hand side is the CONUS weather, the weather for the United States. And that's where I want you to spend some time and go through these charts and take a look at them and start to get familiar with what they have to offer for you. So first off, let's take a look at the quantitative precipitation forecast, QPF. It's a fancy term for basically what amounts to a forecast of how much rainfall or liquid moisture is going to hit the ground over a 6-hour interval. And this is useful again because this goes out to 84 hours in the future. So if we're planning a flight, say we're leaving on a Friday for a weekend trip, coming back on a Sunday, we can start to get a feel for what that weather might be on the return trip. A lot of us fly with family and children and want to have a comfortable flight. Most flights we could complete with some turbulence and some rain, but that's not comfortable for your passengers all the time. So you may want to think about comfort and when the best time of day is to get back if weather is going to be an issue for your trip. So you can start to look at some of these forecasts to see where some of the heavier precipitation is going to occur 2-3 days out in the future. Again, in this case, here in the center, we have a light blue color, which equates to about 1 inch of moisture, probably rainfall in this case, over the western Kentucky portion. So that's a good one to check out when making that long-range forecast. Now, again, this time of year, precipitation probably means thunderstorms also. And so in ForeFlight, and also these products come from the National Weather Service and the Aviation Weather Center, you have a convective forecast and an extended convective forecast. Now, while there are differences between the two, I'm not going to get into too much of the technical background. We're kind of looking at these as big scale planning charts at this point. The convective forecast is going to be your kind of day of forecast. So the morning you have a flight planned, pop open the convective forecast. It's going to give you 2-hour windows, 2, 4, 6, and 8, I believe, out from the current time. And it's going to give you a big picture view of where thunderstorm activity is expected to form. So again, you can see in this chart here on the right-hand side between Friday and Saturday over that 6-hour interval where the likelihood of that activity is expected to occur. And because of these short 6-hour windows, again, it can help you plan flights or plan your schedule accordingly. If you have a flight that you need to make, you sometimes can determine that, hey, if I got an earlier start that morning, I might be able to complete the flight. But if I waited till 4 o'clock in the afternoon in my Bonanza, low level, it's probably not going to work out. So it helps make those tactical decisions in advance instead of letting the weather develop and then you getting stuck somewhere because of the increased thunderstorm development. Another kind of complementary product is the convective outlook. Again, this is the one that you'll see a lot on the on TV, Weather Channel. This is describing the likelihood for severe weather. So now as pilots, we hear the word thunderstorm. Me personally, I don't care if it's a weak thunderstorm or a severe thunderstorm, I'm going to keep my distance. So this chart here is really telling areas of broad scale, large scale, severe weather to develop, but also useful for pilots because you can really see some of the big weather systems and how likely they are to develop both the day of your flight And these can go out to the next really 3 days with some degree of confidence in the convective weather and what you're likely to see. Again, this is another chart in ForeFlight, or visit the National Weather Service website to view this information. And this is interesting because this comes from the Storm Prediction Center, so a different kind of division of the National Weather Service that really focuses on that more severe weather. Now, as Scott mentioned, and I'll kind of reinforce on these convective forecasts and extended convective forecasts, computer-generated models, so they're not perfect. But I will say in my experience, given that these are kind of big picture painting with a broad brush, fairly accurate in terms of their forecast guidance. There's been days I've looked out a couple days in the future and storms were forecast on the east coast of Florida, but if you went on the west coast, it was clear. Sure enough, weather exactly formed just how they predicted. So again, it allows you to kind of make those long-term decisions and help you plan accordingly if you need to be somewhere in your aircraft. Another point I'll bring out here, look at the top chart. It says Thursday from 18 Zulu to Friday 0 Zulu. It basically looks like a cold front coming through. And there's some lighter areas there towards Tennessee, Kentucky, Ohio. It's not always doom and gloom. You know, this whole area is not going to be filled with convective activity from 18 Zulu to Friday evening. It's the chance of thunderstorms to develop over that period. So don't look at these at the same time and just say, okay, there's convective weather forecast, I can't make it. That's probably not true. This is one piece of the puzzle to help you determine where that information is. But don't always just look at these and also just say that, hey, it's going to be the entire half of the country's thunderstorm ridden, because that's not always the case either. But again, just use this as part of your weather toolkit to assess the situation. Now let's head over to the ForeFlight and Maps page. This is where we do a lot of our interactive planning to view the text weather, radar imagery. In one of the layers there, and it might not be ideal the way they have this set up, but they have one toggle switch that turns on AirMets, SIGMETs, center weather advisories. And there's actually one other piece that comes up on here that I want to bring up that's useful, again, for kind of that day of planning tool when you're getting ready to head out on the flight. So the first screenshot we have here is a SIGMET surrounding a line of convective weather. SIGMETs to me personally aren't too useful because they are basically bounded boxes around very heavy precipitation and thunderstorms that are pretty obvious that you shouldn't fly near. Another part that ForeFlight includes now is again called the convective outlook, and that's why I kind of call it convective outlook, the other one, because we just looked at a convective outlook that was a severe weather forecast for broad areas for a given day. What this convective outlook is issued by meteorologists at the Aviation Weather Center. So now we're talking about a human-derived forecast of an area that expects to have thunderstorms that may develop over the next 2 to 6 hours. A lot of times what I'll see here, planning a trip, 10, 11 o'clock in the morning, storms typically fire up in the afternoon. You may see this big yellow bounding box, but see no rain or no precipitation. But what that's telling you is there's a good chance that in that area, there could be some convective weather forming. So it's a good kind of tool to look at as you plan your flight on that moving map page from point A to point B. You're going to look at pilot reports, you're going to look at text weather, but also turn that convective weather outlook on with the AirMet button and see if there's any convective outlooks along your route of flight. That might give you a clue as to what could happen along the way. So again, this is a kind of the usefulness and takeaway from this whole kind of talk on here. This is a convective outlook chart that was issued, I think, the Tuesday or Wednesday of Sun and Fun. So if I really wanted to get from the East Coast down to Florida, and I was looking maybe 2 or 3 days out, and I saw this kind of forecast with the high likelihood of severe weather in that region in Georgia there, and if you may remember, there was a pretty large tornado outbreak. If I'm looking at this 2 or 3 days in advance, I could say, okay, well, I want to get to Sun and Fun. I don't want to miss that. If I can move my flight up a day or two, I could probably make it. But if I really waited until this Tuesday or Wednesday, there's no chance of me getting down there. So when you have flexibility, I think it's important to expand your briefing, look out a little bit more in the future, which may help you accomplish a couple more flights that you may not have, and also make your flights more comfortable along the way. Okay, I'm going to turn it back over to Scott here. We're going to take what we've learned here in terms of our pre-flight planning. We've made the decision to do the flight now, but what are some tools that we have available to us to monitor as we make the flight and keep an eye on the weather as it develops along the way? So Scott, turning it back over to you.
Thanks, Brett. You've done a really good job of really funneling in the focus on the longer term forecast to the a day or two out to now we're going into the nowcast or the short-term forecast. We talked about convective outlooks, we talked about severe weather outlooks, we talked about SIGMETs, airmets, and now we are in the airplane and we have tools at our disposal to make decisions on where we should go or if we should, if need be, get the plane on the ground as fast as we can to avoid getting into a line of severe thunderstorms. Let's talk about some of the tools that you'll have in the cockpit. Your two big options for in-flight data link weather are ADS-B, which is free, and SiriusXM, which costs money and is a monthly subscription. Both have pros and cons, and ultimately the decision is yours on which one you want to choose. Let's at least give you some perspective on what the various tools offer. We'll start with SiriusXM satellite weather. This is for your panel for ForeFlight. It works at any altitude. It works in northern Mexico, southern Canada, coverage for all of the United States. You have reception on the ground, and you have parts of the Western Caribbean, and you can see the box that will go up on the dash, and you can get output in ForeFlight, iPad, but also in your panel as well. So that is the SiriusXM satellite weather option. And then you have the recent to come on board ADS-B data link weather, US coverage. You get towers to your Stratus box, and then you get it in your display. Again, that is the free option. The SiriusXM option will cost you some money. So how does ADS-B work? Well, let's talk about where it's useful. You can see it on the left side of the screen, the FAA estimate at 1,500 feet, reasonably good coverage, and in orange, you can see very good coverage, not just over the continental United States, but also over Puerto Rico, Alaska, Guam, even parts of Hawaii there too. So that's the coverage on ADS-B. So regardless of which option you take, whether it's SiriusXM or whether it's ADS-B, it is important as a pilot to understand how radar works. Radar is a very powerful tool, but as I've said before, with model data, satellite data, with METARs, don't fall into the trap. And Brett highlighted this too. METARs at major airports often update once an hour. You may be waiting for a thunderstorm to come through for the observer on the ground to measure the peak gust and then transmit the METAR out before you know that a change has occurred. So radar and all of these tools that we're using in the cockpit are lagging indicators. You should still be using your eyes to make decisions. You should still be using the information on your tablet and on your panel to make decisions yourself. But let's go into the technology. Let's talk about how radar works. In very simple terms, radar works by sending out a pulse of energy, and then it waits and listens for that energy to return. Using various frequencies, a lot of technology that I'll spare you, the radar knows what time the pulse was sent out. It knows what frequency it was sent out at. So the radar is detecting the amount of energy that is returned, and the radar knows the time that it took for that original pulse of energy to return back to the radar. Also incorporates the speed of light because that's how fast the energy is traveling. So the radar and the processors in the background take all of this information and they create a plot of radar echoes called reflectivity. When you see this on TV, when you see this on your device, you're really looking at reflectivity. You're looking to see how much energy was returned back to a weather radar. But let's expand this out a little bit. Here's a visual of how radar works. You can see the pulses of energy coming out of the radar. So that energy hits a thunderstorm, and then we see the display with the black base map and then the reflectivity on top of it, clear indication that there is rain and thunderstorms in the area. So that's a very simple visual explanation of how radar works. But there are different types of radar data. Let's stay focused on reflectivity. There are two main types of reflectivity. There's base reflectivity, and then there's composite reflectivity. And it's important to understand the difference between base and composite. especially with the advent of all of this new radar data available to you on aviation apps, for flight, and online. Base reflectivity is defined as the lowest elevation radar image from a single radar site. So we're only focused on one radar, and we're only focused on the 0.5 degree above radar level scan, the lowest scan that comes out of the radar. Composite reflectivity is often more of an interest to pilots because it's the display of maximum reflectivity from any elevation angle over every point a single radar samples. So the composite reflectivity image is more of a vertical extension of how strong a thunderstorm or a cluster of rain is. So for a given radar, storms will almost always appear stronger in composite reflectivity than base reflectivity, because sometimes the highest echoes, strongest reflectivities, aren't always close to the ground. So what should you as a pilot be thinking about? Well, pilots flying to altitudes above 10,000 feet should definitely pay closer attention to composite reflectivity, because as we mentioned, composite is more of a composite throughout the vertical dimension of the atmosphere. It's a better representation of a storm's strength vertically. But don't just focus exclusively on composite if you have both base and composite reflectivity to look at, because base reflectivity is more important during takeoff and landing and for lower altitude pilots. It provides a better indication of precipitation intensity closest to the ground. And if you look carefully in these images, you can see a boundary actually on the left side of that radar image. There's a brief line that shows up. That's an outflow boundary. Coming out of a severe thunderstorm, that outflow boundary could create low-level wind shear, and as you might expect, that might be quite hazardous to your takeoff or to your landing. So what you're looking at here in this animation, the left part of the screen is base, and on the right is composite. If you follow the radar animation here for just a few seconds, you can clearly see that the composite, the image on the right, suggests the storm is a lot stronger. But we get more frequent updates, and we can see those outflow boundaries, those little squiggles of light blue coming out of the thunderstorm on the left. So there are advantages of using both. This is probably the most important thing that I can tell you when it comes to radar. Don't let the bad weather in front of you become the bad weather around you. Bret and I have talked about this for quite some time tonight. Radar is a great tool. You can look at weather balloon data, you can look at TAFs, you can look at satellite loops, you can look at everything. Even with the best technology in the world, you still have to use your eyes and look outside of the cockpit to make sure that something isn't developing or changing or evolving ahead of what the guidance, the radar, the tablet, for flight, your briefing, the TAF shows. Also, make sure that you're looking at the timestamps. This is often something that's swept under the rug. We just take the radar as most current, it's updating, no problem. But you may lose a connection. You may not be getting current data into your iPad. So make sure when you look at your watch that the timestamp is pretty close to it. And make sure that you're using the latest data to make the best decisions. And never assume that weather data is live. Remember, with composite reflectivity, we're taking various scans from the radar at various elevations, and we're integrating that to come up with a composite reflectivity image. So it takes time for that data to not just be collected and processed at the radar site, but it also takes time for that radar data to be disseminated to the National Weather Service headquarters and then be processed by ForeFlight and get to your app. You can see how it takes some time to get this information to you from the radar. Trust your instincts. We've talked a lot about how technology can be helpful for making decisions, but you are a pilot. You are in charge of your flight. You are in charge of the people in your airplane. So if you ever feel threatened, don't be afraid to go against the guidance on your tablet. Don't be afraid to say, I don't like the looks of that thunderstorm, and I'm going to get in touch with ATC and make a decision to get away from this. Weather data is guidance. Time and time again, meteorologists, when they're first getting into the business of forecasting, myself included, perhaps for the first couple of years, if I want to fall on the sword a little bit, they easily jump into the models. They usually take what is spit out by a computer and say, that's what's going to happen. But remember, that is guidance to you, use to make your decisions. You have to make those decisions. Your safety is not something that is forecast by the radar. And even in the snapshot, you can see from the SiriusXM data, a possible tornadic thunderstorm. And remember, some of that data is automated. That doesn't necessarily mean that there's an imminent threat. So you should be using your eyes. You should be looking at the line of storms. You should be looking at all of the data that we've discussed thus far tonight, not just looking at the radar picture, but looking at the environment around those storms, the likelihood for storms to strengthen, the likelihood for thunderstorms to develop before you make your decisions. And remember, these decisions can change over time. So with that being said, I'm going to hand it back to Bret, and he is going to tell us more about how to put these plans into action.
Thank you, Scott. Great information there. I always enjoy listening to Scott, and he always has a good perspective on the weather and taking it from that technical view and making it meaningful and useful to pilots. And if the one takeaway, like you said, is the timestamp, and not just the timestamp, but the age of the weather. He really had 2 points there, that these convective scans that are surveying multiple aspects of the atmosphere, that takes time to assemble that data. It takes time to transmit it to the ADS-B network or the SiriusXM satellites. That data is then distributed either on a 2.5 minute or 5 minute interval. So kind of in the back of your mind, play conservative and assume any of this radar imagery that we're looking at. I like to go with a 10-minute old picture, honestly, and that should kind of give you a feel for how far you should be keeping away from it. As Scott mentioned, with your eyeballs, a perfect day, it's a crisp, clear, blue sky day, and you have really defined edges on the thunderstorms. You can see the anvil top, you can see the edges defined out, you can circumnavigate around it without a problem. You know, the stratus is, or the in-flight weather is just there for a supplemental tool. The tricky days are the ones where there are embedded thunderstorms through some of these warm fronts, stationary fronts, where you can't see that convective weather. You know, you're in the soup as an IFR pilot or down low as a VFR pilot and maybe some reduced visibility. And it really makes it tough to know which cloud is amicable and which one's going to send you up 500 feet. So keep that in the back of your mind is really the most important takeaway, that this data could be and probably is about 10 minutes old. So don't use it for that close range navigation. Okay, so let's take that and we're going to expand on that. Scott mentioned really the 2 forms today, 2017, of in-flight data link weather, which is really incredible when you think about the technology that's evolved, and the iPad has really driven the data link weather picture. It took $3,000 to $5,000 in portables 5-10 years ago to get what we can get on our iPads today for under $1,000 in equipment, and sometimes less than $500 really, depending on the product you use. But the product you mentioned, ADS-B, subscription-free weather, a nice part about these products also is they include GPS, so they're going to drive the moving map position of your aircraft on the iPad. They have AHRS for backup attitude, so you have a backup attitude display. They're all wireless, they include a built-in battery, and use Wi-Fi to transmit to your iPad. The product I'm going to go through today and show some examples is Stratus. I was looking at my logbook earlier, and I think I've probably logged about 600 hours flying with Stratus over the last 4 or 5 years, 4 years I guess at this point. So very familiar with the product, and it's really an integral part of my flight bag, just like my headset now. Kind of one of those things you don't leave home without it. And for more information, sporties.com/Stratus will provide that for you. The alternative, and I've been flying with this probably about, I'd say 100 hours now, is the SiriusXM receiver, and it has some great benefits. That ADS-B has some limitations that pilots were looking for. One of those is a high-resolution radar imagery for the entire country. It really has a crisp, clear, high-definition picture of the radar imagery. For me, that's not, you know, a really big selling point, because I care what's around 200-300 miles around me, and for that, both are comparable. But for those flying the higher altitudes, higher speeds in the jets, having that higher resolution data further out can prove useful in decision making. This product also includes a GPS, so it'll drive your moving map position. Now, where it really stands out are some of these premium products that XM has been known for a while, and now SiriusXM provides those similar data products. And that is the ability to display composite and base radar reflectivity. And as Scott mentioned, there's times when you're flying near this kind of weather that the different reflectivities can prove useful. I'll show you some examples here coming up. It does have the lightning layer, and echo tops. Again, very useful for the high flyers. It gives you a clue if you are in embedded weather, whether or not you can top out some of the storms in the 30 to 40,000 feet range if you are flying that higher performance equipment. So with all that being said, the premium features, the coverage into Canada, the coverage into Mexico, Bahamas does require a $39.99 monthly subscription. And that's for the SX AR1 box. That's the new Sirius XM receiver for ForeFlight. Of course, Sirius XM is available in lots of the avionics and panel mount equipment that we're all familiar with also, as well as for a lot of Garmin portables offer this product as well. Nice thing for those that fly long trips that need a little background music is that it does offer the Sirius XM satellite radio now through the ForeFlight app. So kind of a neat addition there if you want to add that on, kind of like icing on the cake to the system. Okay, so the big debate, and you always hear this back and forth, is ADS-B has subpar radar resolution to Sirius XM. That's really not true all the time, accurate. It's really more of a subjective view. And the reason for that is, here's two examples. On the left-hand screen, we have ADS-B weather. On the right side, we have Sirius XM. Both of them are displaying little pop-up thunderstorms. Both of those you're not going to get within a pixel or two close to that thunderstorm without looking out the window to make a difference. The point being here is that these are displaying areas of weather that you want to stay away from. I don't care if that little red block has 15 shades of red and shows a perfect gradient, I'm still going to stay 20 miles away from it. Or if it's a red block like on the left, it's a thunderstorm, I'm going to stay away from it. So you're not going to really make your decisions based on the refinement of the resolution of the radar. Now, with that being said, let's look at an example of a long-range radar imagery. So on the left side here, we're on a flight from Phoenix to Cincinnati, and at this point, we're looking at weather that's in Alabama, Louisiana, Tennessee. You know, this is 600-700 miles away probably from our current position. From a practical standpoint, I don't care how detailed that weather is. It's nice, it looks pretty. I can analyze and see the thunderstorm cells and how they're building up. But the view on the right side tells me just the same information, that I'm not going to be going through that weather. So keep that in mind as you're looking at the radar imagery. A premium of the Sirius XM product is it does show that base versus composite reflectivity. So on the left side, we're looking at that base scan, useful again when flying maybe under 10,000 feet or so. Shows that there's a lot lighter rain hitting the surface than there is up at the higher levels. So if you are in those areas, don't always assume that the total amount of moisture is actually falling to the ground at the airport you're at. So it's a good comparison for those that want more of an in-depth tool of analyzing that radar to look at that base versus composite, which is provided with the Sirius XM service. Over ADS-B, you strictly just have the composite reflectivity. Okay, so we got 5 scenarios here. We're nearing the end here, so bear with me. I know we're going over our time period a little bit, but I think some really helpful takeaways from some trips I've been on across the country to show how things work out when using Sirius XM and ADS-B weather. Okay, so in this case, we're on a long cross country. We see out in the distance there, and this is with ADS-B. So in the bottom of the screen, we see that low resolution distant radar picture. We see there's some convective activity. There's some magentas in there. So we decided to stay north. That's kind of what this whole system is for, to make those long range decisions in advance to stay away from that convective weather. As we get closer, now we're in the Indiana area near that convective line of weather. Now what you see now with ADS-B as you get closer that the resolution did improve. It still tells you don't go anywhere near it, but you can see a lot more detail there with the gradients and that line of magenta. So we're going to stay north, keep the flight moving along. Continue to get closer. We see a big hole, right? Looks like we can make a straight shot there just south of that Brookville Lake and head into Lunken. But as Scott mentioned, you know, what trumps all that is your view out the window. We look out the front there and we see that massive overhang from that convective weather. We're really looking at a cold front here that had a gap in there, but you know as well as me that that's not a fun flight to make through that gap there. So as much as you can watch that convective weather develop and see a hole possibly and see a break in the precipitation, use your eyeballs, and they always veto the datalink weather. In this case, you're going to have to divert further to the north to stay well clear of that building line. Number 2, next point, we always think of the colors, right? Light green, dark green, yeah, not bad. An important part here is looking at the gradient. It takes several miles for it to go from the green to the darker yellows and oranges. So yellow is always bad, right? Well, not necessarily. Again, this is where we can look at the base and composite reflectivity. In this screenshot here, we switched the reflectivity to that base level and see that a lot of that higher decibel reflectivity was at the higher altitudes. But at the surface and below 10,000 feet or so, we're seeing a lot more of the lighter greens. So with the XM tools are helpful because you can look at lightning data, you can look at storm tops, you can look at cell movement to give you a bigger picture of what's going on. ADSB doesn't give you that luxury, so again, that's kind of a premium product to have those additional tools along with the Sirius XM. So what I want to do here is look at the circle spot here on the right. We have the ADSB color and the XM color. For the same exact precipitation intensity, ADSB is going to show green, and XM shows yellow. So again, that's where your training and your kind of knowledge and familiarity with the product needs to kick in. That yellow is not always yellow. It's a matter of what the supplier of the content dictates the color of that radar imagery. So be aware of what product you're using and what that means. Okay, another example, we're heading back to Cincinnati here. Looks like we had a line pass through, and we're always taught weather moves from west to east, right? Development and along the jet stream, along the wind flow patterns. Well, that's not always the case. In this situation, that storm line sagged down to the south, southwest. And the way that you can figure that out in the airplane, in addition to knowing the larger scale wind patterns, is you can animate the radar picture. Down here in the lower left-hand corner is a play button. And you can use that to put the radar picture into motion, just like you can on the ground when you're doing your pre-flight briefing. So very important to take advantage of that animation tool as you get radar data saved in your iPad application, your panel, etc., to animate it to see what's going on. Okay, number 4, this is a flight we did out to Frederick, Maryland, out to AOPA. And we were getting vectored for an approach, and this is an example where you can really put all this information into context. We're not just seeing our airplane now on a big map with convective weather. We can see where we're going. We can see where the final approach path is. So we're able to take this radar data, overlay it on top of the final approach path, and typically when you fly to Frederick from the west, they have you overfly the airport a little bit towards the south and then circle back around. On a day like today, we weren't going to fly through that convective weather. So having known that in advance, we were able to work with the center and then the approach controller to get vectors up to the north. Kind of an unusual traffic pattern for that area, but it kept us well clear of the weather. So by having this information, you can give ATC more of a picture of what you want to do and not let them dictate where you want to go through some of that heavier rain and probably turbulence along the way. So my biggest takeaway, and again, flying with this product, is to make long-range decisions. Don't fly right up to the weather, see it developing, and then make a hard right turn, go around it, continue on your way. Talk to ATC, make a long-range plan well in advance, pick a VOR, pick an intersection to get around that weather. And that's really what it's used for. It'll give you that nice big clearance around it so that you're not butting right up next to it and getting some of that downdraft turbulence or associated turbulence with the convective weather. But make those long-range plans, and that's really the point of datalink weather. Okay, with that, we're going to wrap up. I just want to point out again the Sporty's Takeoff app. It's completely free on the App Store. Scott Dimmich is a regular contributor with video tips and articles talking about weather. Here's one here, 5 tips for using radar to avoid storms. So a great way to keep up, not just weather, but any kind of aviation topic in general, and also have some fun along the way. We put a lot of fun flying videos and articles up there. So a great way to kind of stay proficient and in tune with current events and current training topics. With that, I'm going to turn it back over to Eric and see if we have any questions this evening.
Thanks, Bret, and also thanks to Scott. Let me begin with the accolades. A lot of great feedback throughout the presentation. Thank you for that. I mentioned at the very beginning how imperative it is for us as aviators to be conscientious students of weather, and that's what tonight's presentation certainly was all about. And as we attempt to do throughout the Sporty's webinar series, we try to give meaningful strategies and introduce you to tools so that you have takeaways, so that you can be safer, that you can be more proficient at what you're doing, and tonight was certainly no exception. So a big thank you to Scott and Bret for that. Let's get to a few questions. I'd like to pose a few questions to both of our presenters. I'll begin with Scott. First question relates to forecast accuracy, and my first thought is clearly as the technology improves and as we gather information from more and more data points, certainly the forecasts are probably going to get better. But really the question comes down to, is there some way you can quantify how the accuracy improves the closer you get to your actual window of flight? In other words, Scott, if we're talking a day out, 2 days, 3 days out, is there a way to describe how accurate or how much you can depend on the forecast at any given time?
I think I can quantify that fairly well. Usually when you see on television, you check a weather app, you're looking for a 5 or 7 day forecast. And usually day 6 or 7 are a really good first guess. And more often than not, they're right. But there may be some changes that evolve, going from, say, partly cloudy to mostly cloudy, or going for widely scattered showers to scattered thunderstorms. You might see respectable changes. Nothing tremendous, but usually respectable changes can be expected on day 6 or 7. Up to about day 5, we, as a weather community, have a pretty good handle on the timing of fronts, warm fronts, cold fronts, positions of high pressure. We can usually quantify cloud cover. We can usually classify the coverage and the intensity of showers and thunderstorms at a base level pretty well. When you start to get into the shorter range, your confidence obviously increases, but the coverage of individual showers and thunderstorms really comes down to almost a nowcast. Can we say that in most cases that the coverage or the intensity of showers and thunderstorms will be higher to the north or to the south of an airport, say at LaGuardia as opposed to in Philadelphia? That is where you start to get into the 24 to 48 hour range. And in the summertime, you expect thunderstorms, the coverage, the intensity to be less certain the farther you go out, but also compare that to a significant winter storm. You may hear a heads up on that for 5 days out, and then you might get into totals once the system makes landfall in the Pacific Northwest. So I think generally speaking for aviation, you should trust TAFs and know that those may need to be amended. Specific forecasts for cloud bases, cloud cover, timing may shift by a few hours, but you might expect bigger shifts in the timing up to, say, 12, in some cases 18 or 24 hours as you get 3, 4, 5, 6, 7 days out. So Bret talked about some of the longer range forecast tools, things like ceiling cloud bases. You take those with a massive grain of salt 4, 5, 6, 7 days out. But if you see it in a TAF, usually a meteorologist has actually looked at the sounding, the SKU-T log P that I showed you, looked at the changes in the temperature, the dew point, and has assessed how chunks of air will cool and condense as they rise into the atmosphere or don't rise, so that we have a pretty good understanding of visibilities, cloud types, especially 24 hours out. But bigger systems, you're good to go in the longer range, but just be aware there may be some timing issues and specifics like the exact amount of precipitation, the visibility, the amount of snow that may be covering the runway. That's highly uncertain, and that's usually a call, usually 24 or 48 hours out.
Thank you for that, Scott. Bret, let me pose this one to you. This is a question specifically as it relates to ForeFlight, but you can speak more generically if you wish. But the question essentially is, so many of us, if we're doing some kind of weekend type flying, we're staying within 50 miles of the airport, we're just going out for an hour or so. Describe how that differs or how that changes in one's process of going through a weather briefing, if it changes at all. In other words, kind of that local flight weather briefing versus across country.
Sure. So the biggest difference there, I think, is the amount of time that you're probably going to be in the air, which limits the amount of variability and what can develop over that time period. I still think there's great value in looking at the big picture of what's going on. Again, the surface analysis and the product chart tools of knowing where the high and low pressure systems are. But your actual forecast products you're looking at are much narrower at that point, so that the TAF, the METAR are going to be a lot more important. And one thing we really didn't stress too much here, but it's a good time to bring it up, is the pilot report. I'm going to take a look at pilot reports because I really care about what is happening right now during this given time period. Is there turbulence? Is there, for IFR pilots, icing? And I see we're talking weekend flyer here, so more VFR weather. That's where the radar imagery and that more localized forecast topics. A MOS, for example, can provide more information too, since you're going to be at probably airports that don't have a TAF 50 miles away or so. So you're going to use more of those kind of zeroed-in forecast and current reporting products in ForeFlight, more looking at the moving map of what's going on now and less about what's going on over the next 4 to 5 hours.
Understood. Thanks for that. Scott, one more question for you. It specifically relates to building out a TAF forecast. The question relates to how are those built? I guess it comes down to the question from the audience is, are the weather professionals that are putting these forecasts together, are they looking at many of the same tools that we all have access to, or are they looking at other forms or sources of data that the novice person would never touch?
The simple answer is you're looking at things like MOS, the statistical guidance, but you're also looking at numerical weather prediction. You're looking at both. And you're not just looking at model data, but you're also looking at recent trends. You're looking to see which models have done very well in a given scenario or have done well the last time that a similar weather event happened. So when you're, as a meteorologist, going through things, you're looking at model cross-sections, so you're looking to see what clouds look like, whether there's precipitation in the area, how intense it's going to be for a given spot, but you're also looking over an area to see whether showers or thunderstorms are favored in a certain area or if they're going to stay to the north. And sometimes there are discrepancies, and Bret highlighted the showers in the vicinity often showing up in the TAF. There were some of those in the Cincinnati area today, and yes, I do look at TAFs even as a meteorologist because those are updated more frequently than the other forecast package by the National Weather Service. So I know that even meteorologists, certainly someone like me, especially with an interest in aviation, there is insight that comes from TAFs. But in summary, we're looking at a lot of different model data. We're looking at statistical guidance. We're looking at numerical weather prediction models, and we're making a best guess on timing and cloud bases. And we're also looking at METARs, and we're looking at pilot reports to see if we can figure out where that cloud layer is going to be, when the intensity and the coverage of showers and thunderstorms will be highest. And I think the trickiest part is the visibility. And MOS does a surprisingly good job in a lot of low-lying areas for picking up on fog. So if you're going into an area where terrain can vary or certain spots are more prone to seeing fog, you should look at different sites surrounding your airport. A low-lying area along the river tends to collect a lot of fog compared to areas well away from that river or from a lake. So you might look at various spots in ForeFlight from MOS guidance, but in culmination, a meteorologist is always trying to take the best possible information and convert it into the most accurate forecast they can.
Excellent. Thanks for that, Scott. We will, with that, we will close things out for this evening. So I wish to again thank both of our presenters, Scott Dimmich, Bret Koebbe. Excellent job this evening. I'll remind everyone as we conclude that we did record tonight's presentation, and it will be available sportys.com/webinars. So please check back, and also please check back for future presentations you may wish to attend. And thank you for being with Sporties here tonight. On behalf of both Scott and Bret, I wish to bid you all a great evening and hope to see you back sometime very soon. Safe flying to all.